Hello. I have, changed the game a little bit with the robot, the homebrew robot. With regards to the this motor control board, remember the one that I removed one of the connectors so that I could use the pins for a UART to the ultrasonics board, so I could use that as communications to the ultrasonics board. And I cut the pins too close to the board, and I couldn't get them out. They're too tight in there. I couldn't get them out using solder wick. So I'm waiting on a solder sucker from eBay, and so while I was waiting, I found on eBay these other motor control boards, but they don't sit on top of Arduino. They sit aside. You can control them with Arduino. They have a set of control pins right here, and you can control them with Arduino. And in fact, there's several places out on the web where people have actually done this, and they give some good diagrams. And I didn't see any good code, though. I would have to write my own code. But I saw some good diagrams where they just what pins they use. But you could use any pins. I don't think actually I'm going to need that. But it does at least tell me that somebody's done it, so it works. And these don't sit on top of the Arduino over here, and so not going to take up any of the pins other than what you use to control. And then I can just run wires over to here for the control. This is the power to the motors, and then here's motor 1 and here's motor 2, or left motor, right motor. And it uses the same device. The heat sink's a little smaller, but that should be alright with these particular motors. I did a current power usage analysis on them at one point a long time ago, and they don't even get warm when they run. They do a real good job. They're geared very, very low and don't use that much current. So I think we'll be okay there. But if you're getting beat at chess, play checkers. That's what I say. So that's what happened. I was getting my butt kicked with this board with where I pulled off the connector, and I'll use this for something else. It'll definitely go on something else. I'll clear those out with a solder sucker when I get it, and it'll definitely be used for something else. But for this, I can use this board now and continue on with the robot building. Well, I'm going to have to drill, and then I put some holes in there. I've got the motor control board is mounted, and the holes were already there for that. Now I've got to drill some holes for the Arduino, and that will free me up to connect the two. And then I'll have all the pins I want for my crazy UART, so that I can talk to the ultrasonics board and pass information back and forth. So we can finally get the ultrasonics mounted along with the display, and have this thing, do something intelligent. So I'm not going to bore you with the actual drilling process, but just want to let you know where I'm at. Well, you knew I was waiting on a solder sucker so that I could put a solder in the cable from the display ultrasonics display board to the motor control board, and here it is. It came in. It's the Greenlee PA1700. Greenlee Communications is the name of the company, and it's their PA1700 solder sucker. It says it removes solder with a simple push of the button. Well, we'll see about that. But Greenlee is a good company. I mentioned that. I worked with them before, and they're very keen on on quality, if I can get this out of here without dropping it. Nice little case there, easy open package. But there it is. Yeah, it's a solder sucker. Ooh, you hear that sound? That's a good sound. And you notice it's not perfectly round. It's got kind of this flattening all the way across, beveling, what do you call that? Or all the way around, rather. But that ought to take the solder out of the hole. You don't want any solder in your hole, that's for sure. So that's what we're going to use. That's my solder sucker. I wanted to show you that. And now we'll look at the the reason, back to the reason why I don't really need it, for at least I need it, but not for this particular reason anymore. Well, here's the motor controller. I got some new lighting, but I don't know if I like it. It's kind of behind me, but I can move it around, but it's casting these shadows. I don't know if I'm going to like that or not. I'll have to move it around a lot. Anyway, this is the motor controller I'm going to use on the robot. I've showed you. I've got one mounted on there. And let's see how this lighting holds up here. It's hard to tell. Hard to tell there. Anyway, there's one mounted here. This is the motor controller. Here's Arduino. Now it's mounted. I think the last you saw me, I was drilling a hole for the Arduino. And so there's our Arduino. I got some wires between them. I think that's all I'm going to need. And I'm setting up a 5-volt. That's the communication wires there, and I'm setting up a 5-volt power supply, which is here. These are great. I really like these. They're switching power supplies. There's the big fat inductor. Here's the chip, and I don't know the. Let's see. Hang on a minute. Let me see if I can read the chip. It usually requires a magnifying glass. I should know this already. Okay, it's the LM2596 buck converter, and of the specs, it's 3 amps output maximum. Output voltage 5 volts. Well, this one is variable. This one is this particular one is variable, so I can put an output. Oh, I don't know, anywhere from like 3 to 12 volts, something like that, depending on the input voltage. And it's a switching frequency of 150 kilohertz. Let's see, for those of you who are really interested, the rectification mode is non-synchronous rectification. And the conversion efficiency is 92%. Yeah, right. There's probably, there is probably at some point you can get 92%, but I doubt if it stays right there. Let's see, 30 milliamperes. Huh? Output ripple, 30 milliamperes. I think they meant millivolts. And let's see. And that's it. But that's the it's a buck converter, of course. Switching, and nice big fat inductor, which I like to see. And this is going to take my LiPo battery and here, which of course it won't be in this tape, it'll be positioned differently somewhere. My LiPo battery, in fact I'm probably going to need a couple of these for different reasons. I may need 3 of them to supply different circuits with different voltages. And it's going to, this one's going to supply the Arduino right now. The Arduino and anything that needs 5 volts up to, you know, a couple of amps. And then here's my terminal blocks. I'm going to put these on for ease of use there. And so I won't need this one, you know, because I've got the one there that you see wired up. He can handle 2 motors, and so we'll get that done, and that should allow me to, after doing all of that, I will freed up all the pins on my Arduino. Here I'll have all my pins freed up except just a few that are being used for the motherboard to talk to the display board, the ultrasonics and display board, to talk to it so that I can get a reading as to a position and a distance, and give me some idea of which way I want to go, which way I want to drive this thing. And it'll be one piece of information of many. And then we've got the IMU, the inertial measurement unit, we've got those other things that we've talked about. And okay, so let me start getting to work on that, and I'll get back with you. Well, just as an aside here, I've just received in 3 chips from an eBay seller. I don't have it right offhand which eBay seller, but I got in the LM2917N, which is a frequency to voltage converter, and here's a typical circuit for that. Looks pretty simple to build, and I thought I would build that up and just play with it. What has that got to do with a robot? I don't know. Don't think it's going to have much to do with it, but I think it'll be fun to put that together. The second one I got is the second one I got is a PT2399, and I got 3 of those in the pack, or 5 in the pack. Very low price. It was like a couple of dollars. It's an Echo processor. I have actually had one of these before, but I lost it and didn't build up the circuit I wanted to. And this is the data sheet for the PT2399, and they call it the Echo, the audio processor IC. Let's see, it's equipped with an ADC in the DAC, high sampling frequency with internal memory, digital processing. It uses generated delay time. And it's, of course, being an Echo, basically it's going to be a delay mechanism. And I was trying to see what milliseconds, because 20 milliseconds delay gives you a really good echo. When you have a 20 millisecond delay, what's coming out of the device that's making the sound, and you delay it 20 milliseconds later, you'll get a really good effect. That would be the classic echo. Let's see. There is the pinout configuration for it, and then they have a typical application circuit. That doesn't look too bad. A lot of resistors and capacitors. Filtering, no doubt. Let's see. You got the output here, the input. So the input comes in, goes in. I can see, yeah, you got he's filtering coming in. He's just filtering all over the place. And then you have this 50K pot here, which probably is your, determines the delay itself. what the delay is. But I didn't see external resistor having a value of 10 k ohms to 50 k ohms may be used. The recommended resistor value, blah blah blah. Increase, yeah, you increase the resistor value, increase the range of the delay time. The delay time also increases. Yeah, that's what we thought. Surround sound, surround delay application. I'm guessing that's something like surround sound, maybe. Which is how surround sound. This would be a poor man's surround sound circuit, would be my guess. Let's see, resistor and delay times. Oh, okay. All right. R 27.6K. Yeah, everybody's got 27.6K in their box. Yeah. What is that going to be? That's not going to be that, but it's going. You can get something close. 342 milliseconds time delay. That's a lot of delay. That's a third of a second delay. That's way up there. Okay, let's go down the chart here. I know you can't see my cursor, so we're at 68 milliseconds. Here we're at 38 milliseconds. And here the lowest they have is 31 milliseconds. So clock frequency 11 megahertz, 18 megahertz. Okay, so it's depending on the clock frequency going in and the value of R, delay time. Well, those are larger than I would have thought. I mean, a third of a second is a long delay. For any kind of, it's echo. It's what it says, audio echo processor, and that would be an echo. But the need effects happen around 20 milliseconds, 10, 20, 30 milliseconds. That's when your ear plays funny with your ear and makes you think you're in a, by playing with that you can think you're in a big auditorium or something like that, even though it's just coming out of a small radio or something. Those are fun to play with. And the third chip, is the TL431 ACL. And I got 10 of those in a bag. And these are programmable precision references. And you program them, I imagine, I haven't looked at this data sheet yet, but I imagine you program them with a couple of resistors. Reference voltage tolerance at 25 degrees. Let's see, 1% A grade. What have I got? I've got the ACL, so let's look at that one. Let's look at the ACL, where that is on the grade list. 1% is A grade, 0.5% is B grade, 2% is standard grade. Yeah, but what is the ACL? Is that okay, I've got the A grade, which is the 1%. All right. If I'm going by up here, I have a TL431A, and then a CL at the end. The CL will mean something else, and so, but mine ends with an A, and so the A is going to be 1%. So we're not the 0.5% B grade, but we're not the 2% either. Let's see, low output noise, yeah, 0.2 ohm typical output impedance. It sinks 1 milliampere to 100 milliamperes. Well, that's pretty good. Adjustable voltage and current, those are applications. Zener replacement, voltage monitoring, comparator with integrated reference. 3-terminal adjustable shunt regulators with specified thermal stability. And let's see, the output voltage can be set to any value between V reference approximately 2.5 volts and 36 volts with 2 external resistors. There we go. These devices have a typical output impedance. Okay, you told us that. 0.2 ohms. Excellent replacements for Zener diodes. Let's see. Just bear with me here. Oh, I think we saw an application. There it is. Well, that's a simplified schematic. Right here's a simplified schematic. Your input voltage, and then your one of the terminals tied to another terminal, and then your output, and then V reference there. So there's the different packages. I've got the 3-pin package. Looks like a TO92 package. It's the 3-pin. Looks like a transistor. All kinds of good data on this. You just imagine the people that put these sheets together and the endless hours they spend, you know, graphing, charting, gathering the data, going over and over it time and time again, just so that we can zip by it and test. There's a test circuit. Well, the test circuits are okay to go by sometimes. They're usually more complicated than what you really are after to do. And well, there, as you can see, there it is. Here's your output, your ground. This is a test circuit, but this is for a pulse generator of 100 kilohertz. They're doing some sort of a pulse response there. 220 ohm there, but you just tie up these two terminals, and then you get your output, and so you see what your you get your desired output. But what I'm looking for is the reference, put reference. I built these up before, just don't remember. Well, let me find it. I'll be back with you. Here's probably the best way you would hook it up, or I was just looking for the simplest, not an example of where to use it in a larger circuit, but just the simplest way to hook it up to to have it work. And this one, I think, has that. Just you can ignore this, and you've got the device going to ground, and you've got a 10K, a 10K. You know, both of those are at 0.1%. Of course, those are your what's determining those are your reference resistors. 10K is an output, and then 6.8K coming down from 12 volts, and that will put 5 volts. Because of these, both of these are at 10K, that will put 5 volts right at the output of this TL431, and then so now you've got a precision 5-volt reference used for whatever. And I think that is cool. Do I need 10 of them? I don't know, but I don't think so. But that's what the minimum they sold them in a pack, and it was like $2, so the minimum amount. So they'll be fun to play with when we build those up. I will share that with you, and if you're interested, we'll build especially the echo processor. I want to see how that works. I want to see how that sounds. See you on the other side of once I start getting I got to drill some holes for the robot and start getting it going.